Hi, we thought we'd put out a short part two video discussing some of the decisions we're making in the design that'll allow people to think about it as we prepare the next video for part three, where we'll implement this design. But it's worthwhile to get the design concepts out early, allow people to sort of think about their own games and how they might make either the same decisions or different decisions than we are. So we're in our persistence chapter where we're tying together our Lyra starter project with our open world server persistent database layer. And in our first chapter, we talked about how we implement the open world server and started the connection between the open world server and the Lyra project. So in this video, we're just going to talk a little bit about the structures and some of the decisions we've made. So the first decision you had to think about, which is what actually needs to be persisted in the database. And what it fundamentally comes down to, at least in our design in this series, is we need to save the inventory manager. So for each instance in the inventory manager, we'll need to save that record. And for each of those records, we'll need to save the various stat tags. So the stack count, which is a tag counter, whether or not it's in a particular storage location, which we've enhanced our design a little bit there, whereas before 0 was on player, 1 was in storage. We realized that model can be easily expanded to say I can have multiple storage bins using 0, 1, 2, 3, 4, and 5. So if I wanted to have towns with different storage locations, I think New World did that, right? Where you had inventory in different towns, but they were not the same. You could just assign a number to each town. So inventory in 1 could be in one town, inventory in 2 could be in another town, and 0 would always be on the player. So that's an enhancement to the storage stat tag. We also had our skills that we activated. So when we activated a skill, we were flipping the stat tag on the skill item to denote that. And then when we slotted an ability, we also recorded which of the 3 primary slots that ability was in. So basically what we need to store is looping through the item manager, storing each of the item instances and their various stat tags. We do not need to store any of the static data. So we don't need to take any of the attributes off the item definition because those classes are static. We don't need to deal with any of the fragment properties, whether that was the icon, the skill point costs, etc. Those are all static. We don't need to store the max stack count. Now, you may choose to do that if you wanted to allow people to increase the max stack count and store that tag as well. But for now, we don't need it. It's an easy add later. So that's what we're going to attempt to store and retrieve from the database when we connect to the world. So how do we store it? So the 2 little screenshots here are out of the database layer for open world server. And in our first video, we talked about the register user and create session, which are both public APIs. The third API that we'll have to call is the create character API, because everything in the system is defined around a character. And we'll talk a little bit about that later, but basically we'll need to have a create character in our design. So we have a character record. And then we're going to be using 2 of the character persistence APIs that are going to be accessed either the add or update custom data or the get custom data. So obviously the get is what we'll do to pull our inventory from the server. The add update will be what we do to update the data on the database server. And as we said in our last video, we want these to be in-world only. Therefore, they're only called from the server to avoid any potential cheating where someone might log into their local copy and want to give themselves a bunch of items through some trickery. If you look at the if you look at the bottom screenshot, this bottom layer here, once we define a character ID, so this character that we'll end up creating in our code, that character ID can have any number of custom field names. And so we can have as many rows as we need for different custom field names, and that those values for that custom field can have multiple elements in it as well, right? So it can be a one-for-one relationship, or it can be a one-to-many relationship where you have many fields with their corresponding value against a custom field name. So that is kind of how the data is stored and structured, and that'll be the approach that we need to align to with our Lyra project. So that leads you to your character relationship. And there's primarily two user to character relationship. You're either in a one-to-one relationship where one user has one and only one character. The benefit of that is we can auto create the character whenever we do the register user. So as soon as I create a user, I can go ahead and create the character at the exact same time. That still supports character customization. I can still have cosmetics, different looks, skins, character morphing, all of those things. But I'm essentially building one character that represents our player in the game. And there's lots of examples of that, right? So the quick ones that came to my mind, whether it's Breath of the Wild and Zelda, where you're a bespoke character and you really, there's no editing, Zelda. Or in Hogwarts, where you customize a character, you make it look the way you want, but then you play as that character through the game. Or examples like League of Legends or Overwatch, where you have you're one player and you pick characters that are only match based. In other words, those characters, you play them through on the match. You may have to store some attributes in the back end, but essentially the characters are limited to a match and therefore not necessarily a character-user relationship the same way we'd have with the other two games. All of those would work in a one-to-one relationship model. If you need a one-to-many relationship model, then that introduces a couple of new complexities, right? You need to be able to create the character via the user, not just via code. You'll need to have a character selection process that allows you to pick which character you want to play with this time. You may need to pick a class, traditional sort of class-based systems, and then delete characters exposed to the user as well. So that's basically most traditional MMOs, where you have multiple classes, you have multiple characters, you level each one independently, and they all have their own inventory systems tied to each of those characters. And so the first major thing to think about is whether the relationship between the player and the character is one-to-one or one-to-many. So that will dictate your overall design for your persistence layer. The next major decision you need to think about is how are we going to represent the inventory in that custom data field that we just talked about. And we think there's primarily three options for us to consider. The first being one custom field for the entire inventory data. So it's basically one big nested blob of items with their attributes. If we make a change, we're going to need to read and write that entire blob. And it's probably best if there are infrequent changes where you have to write back changes to the item, your inventory manager, right? So an example where I could think of is where maybe you complete a match and you're awarded, 4 or 5 items. That's kind of a one-time at end of match event. That would be perfect for a one custom field because you only have to write it once at the conclusion of the match, and the player has it from that point onward. The second one we looked at was supporting different structures per item type. So having one custom data field for skills, one custom data field for recipes, one custom data field for abilities, etc. That's less data for changes. So if we say change an ability, put it in a slot, we only need to write the ability custom data. We don't need to deal with all the other data. And so it'd be less parsing, less looping, it would be sort of less effort at that point when you're making the change to either the ability or something else. And then all the way to the far right, what if we had a custom data field per item? In this case, we'd have a sort of a common structure. The layout of the structure would be the same. We would separate it by some field, which will likely be the item definition name. It would be minimal data up and down for each individual change. So if you think about every time you changed an item, used an item, etc., you'd only have to write that one item back to the database. So if you're doing a lot of frequent updates and you have a rather large set of items, then this might be a better approach. The fetching, the downside of this is that the fetching of the inventory will be a lot of asynchronous calls, right? So if you had 50 items, then you're trying to pull and process 50 individual records. There's probably some looping. It might get complicated. We haven't explored it fully yet, but it might become complicated. The other thing we need to think about is, what if we have multiple stacks of the same item? So if you think about kind of classic MMO style where I've got 4 or 5 stacks of logs, then the item ID doesn't become a unique key, and I'll need to generate my own unique key in order to track and support which of those stacks am I dealing with. Like, the last thing you want to do is use one item off of one stack and have it reduced off the other stack. So it could get complicated when you allow for multiple stacks of the same item in your inventory. So those are the 3 options that we looked at. The good news is, regardless of which of those 3 implementations we end up using or you end up using in your game project, they're basically the same tools, right? So there's 2 functions that we're going to be using. One is to convert from a struct to a JSON. This is how we'll basically convert the data in game into something that we can send over the API to the database server through a JSON file format. And the other one is the opposite, taking the wait, did I get that right? Yes. The first one is converting it from a JSON to a struct. The second one is converting it from a struct to the JSON object. So bidirectional conversions between the JSON file format and the Unreal ustruct format. And so we'll use that regardless of which of the 3 methods you choose to use. It's really the size and bulk of the payload that you're dealing with. So we took a quick look at some of the situations that we'll have to deal with, and then try to assess, prior to writing any code, how easy or hard will each of it be, regardless of which of the 3 item storage methods we chose to go with. So if you look down the list, right, so the first one is on loading and startup. Obviously, we need to go get all our items from our database and then load all those items into our inventory manager. If I have a single custom data field, it's pretty simple. I make one asynchronous call, I get that item data, and I just parse it into my item manager. So that's probably the easiest of all 3. If I'm dealing with a by fragment, that might be a little more complicated. I may need to do multiple asynchronous calls, or at the very least, I may have multiple definitions that I have to process through, right? So in our scenario, we have about 7 to 10 different fragments. So that might mean 7 to 10 different sort of processes. And if it's on the item level detail, that might be the hardest, right? Because we may have to fetch 50 to 100 sets and then process that. Again, we don't know until we actually start coding it, but this was sort of our early hypotheses on which of those would be easiest versus hardest. Then when you earn a new item, and this is where things start to get a little more different, as you see from the table, let's say you pick up a new item in the world. Well, if I have one inventory custom data field, then I have to serialize the entire inventory and upload that to the database. So it's kind of bulky. It's not complicated, it's just bulky, right? I'm sending more data than I need to. I'm having to loop through a bunch of records. formulate a string and then pass that string to the API. If I'm in a fragment scenario, the complexity is what fragment did I pick up? Also introduces a challenge. What if I have an item that classifies as two different fragments? We don't currently have that, but you could get into a situation where you have an item definition. There's no technical reason it can't be both a currency and a resource. All right. So there's scenarios where you might have an item that's representing two different fragments, and then you'd have to make sure that you're only writing it once to the database. Obviously, the easiest would be a single one-for-one where I just write that item into my custom data field and I move on. Similar for the next two, when you use an item, you're using one of the charges, one of the stack counts. Again, in the one database, you got to bulk serialize the whole data structure, send it up. In the medium, you need to figure out which fragment you're dealing with. And that's the same thing if I move it from inventory to storage. All right. So all three of these basically ended up in the same scenario where it's a bit bulky to have to push all that data every time. It's quite easy if it's a single item. On combine, again, we got a kind of medium complexity. On the single one, you have to parse through, figure out which one is no longer valid. Actually, it's not that hard. I guess it's going to not be in the JSON string. So that's probably easy. The fragment is easy because you're only ever going to combine the exact same item definition. So therefore, it would fall into the exact same read-write record. And it's easy. It's medium for the item because you had two item records. Now you have one item record. So we actually have to go from one record, or two records to one record. When you earn a skill point, again, bulky for the all definition, easy for a single because we know it's a currency, easy for an individual item. We're just going to write that skill point back. When you spend a skill point, we put medium under the one record and medium under all of them, because essentially when you're spending a skill point, you are getting a skill and you're losing a skill point. So there's two records that have to be dealt with, the currency skill point and the actual skill that you got for the spend. On reset, also medium, you've got to loop through, return the skill points, and grant the skills, or remove the skills, sorry. And then on slotting the ability, again, similar to some of the earlier ones, it's easy because we have a single, we know it's an ability, therefore it'll be the ability fragment. It's easy for a single item because it's a single item, and it's bulky for one. So pros and cons of both. As we think about which of those makes the most sense, we first eliminate the fragment. For a couple of reasons, it seems like it's an incremental layer of complexity. It's going to be harder to do. The benefits probably don't outweigh the costs. And so then we kind of got down to either one fully loaded bulk or each individual item. So what do we end up deciding? So for our design, two things are going to happen. We're going to do a one-to-one player to character ratio. We don't need the one-to-many. We don't need the multiple classes. At least for this stage, it makes sense. And we'll auto-create that character when we register a new user. So because the create character is a public API, there's no reason not to call it at the exact same time as we call the register user, setting up both the user record and the character record at the exact same time. On the data side of the equation, we opted to go for at least out of the gate, the one custom field. We may very well move to item. We are not going to move to fragment. It's easier for our first design. You say it's bulky. It's a lot of data back and forth, but it's not hard to code and configure. We can monitor our overall performance, and if we see performance is not as we would like it, then we can shift to the item-oriented structure, although we'd have to figure out a solution to the duplicate stacks problem. And one of the big reasons was that the Lyra inventory manager has really two ways to pull items out of the class. One is the get all items, which basically just gives you every item in the inventory manager. And if you watched our prior videos, you'll see that we've looped through that multiple times. So we'll end up having to use the all item, loop through it, serialize it, and send it. Now, it means that because we're going to take this approach, our routine can be fairly compact. We can optimize the routine, and basically on any change, we're just going to call the sort of refresh database, and it'll serialize the entire inventory structure out of that one item. The other option that they offer is the first item definition. And so that doesn't allow you to get multiple item definitions. It only takes whichever's first in the array. So because they lack sort of a more succinct way to pull items out of the inventory manager other than all or first item definition, there is no by fragment that only extracts items with a particular fragment. So you basically end up doing an all item loop anyway. We felt it easier to start off with this field. And then as you think about the data that we're actually processing, right, we're going to have our class string, which represents what the item stack is in inventory, and then 4 or 5 different integers that represent the values against the stat tags. So we're likely less than 50 characters per item. If we have about 100 items, then we're like 5,000 characters in the JSON, which is not a super large payload. If you get up into 1,000 characters, you're now at 50,000. Or if you're to 1,000 items, you're now at 50,000 characters. And so you might be seeing some performance degradation as you loop and build that string. But we're going to monitor it, do some tests, see what the performance level is, see where it breaks. We still have to do some stress testing on the entire Lyra inventory system, and I think they've recognized that as well. But for our go forward at this moment, we're going to be doing a 1-for-1 with the character, and we're going to serialize and load the entire inventory in one custom data field on the open world server. So thanks for watching. Look forward to part 3 when we finish coding this all up. Hopefully get that out to the community to have a look at. If you liked the video, or if you have comments and thoughts, then please leave a comment below. Maybe there's something we're not thinking about. If you've got a brilliant idea, we'd love to hear it. All right, thanks again.